Hello, statistics student. This video is for chapter 9.1, 3 and 4. We continue with hypothesis test basic. We're in part 3 or part C of hypothesis procedure. The last part is about making a conclusion of an hypothesis based on rare event rule and based on the values that we calculate earlier from a sample. Okay, so before we do that, I want to talk about how this rare event rule can be made, or what is the essence of a rare event rule. Just a quick review. So the rare event rule say that if under an assumption an observation is very rare, how rare? Rare than whatever unlikely probability that we have established. So by default it's 0.05. And then if this observation is very rare, but we observe it, we see something that is very rare happen based on an assumption, then we conclude that the assumption is not correct. Yeah, that is, we reject the original assumption. So rare event rule only can do an objection, rejecting. So this is actually common sense that human beings actually do in a daily basis. So for example, someone tells you, I am going to toss a fair coin. So it is a fair coin. So half of the time is head, half of the time is tails. And suddenly I observe 6 heads and 4 tails after I toss 10 times. Not suddenly, actually, most of the time it is, right? So can you just say that, oh, you have 6 heads, more than 5 and 5, that it is not a fair coin? You don't do that. Why? Because it is quite common. It is not a rare event to have 6 heads and 4 tails. And in earlier lectures, when we do binomial distribution, we actually find out that even have 7 tails, 7 heads, 3 tails, those are actually quite common, not rare event. So if you see something that is not rare, an observation, your assumption of a fair coin is still established. So you cannot do any rejection, cannot conclude, cannot based on the fact that you have one more than it is the average, that the coin has any problem. You cannot. So I am doing double negative, right? So cannot say that it is not fair. So because of you don't have any evidence, you would say that, oh, the coin may be still fair. So what about the second observation? So you can pick up another coin, but when you toss 10 times, you get 10 heads and 0 tails. And in binomial, we actually calculate 10 heads is very rare, right? So use binomial distribution, you can actually calculate what is probability of having 10 heads is less than the probability of this happening is less than 0.05. It's a rare event. It's not supposed to happen. So rare event rule said that I observed something, but this has occurred. Just remember, this is an observation. You see this in real life. What would you do? You would say that this coin is not fair, right? Conclude, coin is not fair. Well, I think in real life you would try again, right? But actually, you can, if this is what you have, you cannot use it to toss another time, then you would reject your assumption. Without doing anything, you actually, when you toss something, your assumption of a fair coin is being rejected. You see how we always use this wordings to reject. We never say we conclude that we support that it is a fair coin. We can never say that it's a fair coin by one sample, but we can say that I'm not rejecting you, not reject. Okay. So there's two conclusions from rare event rule is you are either rejecting your assumption or not reject your assumption. Okay. So once we do that, let's go back to our hypothesis testing. We have been basing on, what is our assumption? We have been basing on the null hypothesis as our assumption. And then we calculate probability using calculator, right? Earlier, in this last step, there's two things that we have calculated, test statistics and p-value. P-value is how likely you are to get your observation if X0 as the null hypothesis is true. Right? So remember, P-value is actually not, is a probability of you will have your assumption, you will have your sample if the null hypothesis is true. You already have your sample, it has happened. So there's no such thing as looking at what is the chance of having my sample. You can only calculate, I have this sample, but if X0 is true, what is the likelihood of having that sample? So the way to do it is, if your sample is very rare, just like when we have 10 heads and 0 tails, we reject our assumption. So you would say you reject the null hypothesis. P-value represent the probability of the sample, right? How likely you are to get the sample. And if it is less than alpha, alpha is what it is unlikely. So most of the time is 0.05, but you can choose anything you want. So if it's less than that, we have a rare event. So it is a significant rare event, right? Rare event happen. But we see it because we see that we get that sample. So you reject the null hypothesis. So you have a significant result. You have a significant sample. Sample is significant. Significant sometimes means, oh, I'm very surprised that I get that, based on whatever that is accepted true. But if our p-value is greater than alpha, just like when we have 6 heads and 4 tails, we cannot reject anything. We say fail to reject the null hypothesis. Fail to reject the null hypothesis. So if you see something rare, you reject the null hypothesis. If you don't see anything rare that is in line with X0, you say you fail to reject the null hypothesis. So the way to remember this is, if the p-value is low, the null must go. P-value is high, the null will fly. Okay. But the null hypothesis has nothing to do with my claim. So what am I doing with my claim? So the way you make the final conclusion about your claim, this is the most important, right? The whole thing is because we want to talk about the conclusion of the claim, is if the p-value is a low value, is less than or equal to, then we say I have sufficient evidence. Because when you see something rare, you can actually make a conclusion in the rare event rule. So you use the wording, use sufficient evidence. Now, if the claim is actually X0, then you would say you reject, because X0 is your assumption. So you use the wording reject. But if your claim is in the alternative hypothesis, you would say support. You would use the word support. So let's do some practice. Now, these also can be, the wordings in the conclusion can also be read out from a flow chart. So the flow chart has this word to, but it's based on what you have done in terms of the whole thing. Okay. Let me open up the flow chart. Well, I didn't have it open. So let's see. Maybe I'll open up the flow chart. So when we do the example, we will just follow along and use it to. There's multiple way of making the conclusion. Some people like the flow chart. Some people can just use the wording perfectly okay. Yeah, so this is the flow chart. You can use this to make conclusion also. So let's go back to here. So continue with some example. So let's practice doing the conclusion. If significant level is 0.05 and p-value is 0.04, that means my sample chance of happening is 0.04. What should I say? So you would say, is this a rare event? Yes, right? You would say the p-value is actually less than 0.05. So it's a rare event. So you would say you reject X0. Right? So that's what I write down. And but the second example, if significant level is 0.05, but my p-value is 0.006, what should I do? Okay, so don't look at the number 6. It is 0.006 is a low number. It's less than 0.05. So the sample again is significant. It's a rare event, right? It's a rare sample. Rare sample not because it is rare. It's rare sample based on X0. So based on x0 being true, so you reject x0. Kind of like based on the fact that I assume that coin is fair. Okay. The third is if my significant level is 0.01, my p-value is 0.03. 0.03 usually is actually low number, but if I choose my significant levels to be so low, 0.03 is actually greater than 0.01, then my sample is not significant. So you write fail to reject x0. So this is the only word you write. I cannot reject x0 because all this p-value is based on x0. How about the last one? If the claim is in x0, so this is about making a claim conclusion. So this is a claim conclusion. And so your claim is in x0, so maybe it's a greater than, equal to, less than, equal to, less than or not equal to. But earlier you failed to reject 0 based on p-value. What is the claim conclusion? Okay, so if you fail to reject 0, you must use not enough evidence, because that means the sample is quite good to x0. And if you don't have enough evidence, but your claim is an x0, you use the word support. You connect them together and you say there's not sufficient evidence to support the claim. Not support the claim. Because x0 is okay, right? You fail to reject x0. And then your alternative is actually the claim, then you can't say anything about the claim. It's the opposite. Next one, if the claim is x0, so maybe you're claiming that you're defending something, right? But you reject x0 because of a rare assumption, rare sample. What do you say? Then you say there is sufficient evidence to reject the claim because the claim is x0. So we can actually, whenever you have reject 0, you use sufficient evidence because you're surprised. And then if the claim is x0, you use reject the claim because claim is x0. So let's look at the flowchart. The flowchart actually also can help us. Say here, if I have a claim is x0, right? The claim is x0, and you have reject x0, so it's like here, then it's box number 1, there's sufficient evidence to reject the claim. And in the last example, if the claim is H1, H alternative hypothesis, but you fail to reject X0, let's see, X0 is the claim, but you fail to reject, so you say box 4, there's not sufficient evidence to support the claim. Not sufficient evidence to support the claim. So you can use this wording notes to do the conclusion. So this is a note that we use, or the table that we can use, but you can also use the flowchart. Okay, so I have 3 more examples that I want to go through that has the full practice that include writing claim as well as making conclusion of x0 and the claim. So I'm going to do it in the next video. But this particular video is about making conclusion. So you have 2 conclusions to make. The null hypothesis conclusion, part 1. So you only look at p-value. Your conclusion is either reject x0 or fail to reject x0. And then you have a conclusion about the claim, and you would have to look at where your claim is and where you would say there is sufficient or not sufficient evidence, basing on whether you have a low p-value or high p-value.